Hello, geometry students. Today we're going to learn about polygons and interior and exterior angles of polygons. First of all, I want to let you know that we're only going to be talking about convex polygons in this course. We're not going to be talking about concave polygons, polygons that have sides caved in like that. We're going to be talking about convex polygon in this video. The first theorem is the polygon angle sum theorem, which says the sum of the measures of the interior angles of any polygon that has n sides, or an n-gon, a polygon with n sides, you can find that sum by taking the number of sides minus 2 and then multiplying that difference by 180 degrees. So for an example, if you wanted to find the sum of interior angles of a heptagon, n is 7, there are 7 sides, and so you would use your polygon angle sum theorem, and you would plug in a 7 for n, because n is the number of sides, there are 7 sides, and then you would solve, and you would find out that all these interior angles add up to 900 degrees anytime you have a convex heptagon. I may not say convex on every slide, but know that all the polygons will be convex polygons. Here's some vocabulary that's important for this section. You need to know an equilateral polygon is a polygon that has all congruent sides. The sides are all congruent to each other. An equiangular polygon is a polygon where all the angles are congruent to each other. And a regular polygon is a polygon that has all of that going on. All the sides are congruent to each other and all the angles are congruent to each other. That's going to be a very important definition for this video, and also when we get to area formulas in the future. Now this next formula is only if you have a regular polygon, meaning all the sides are congruent to each other and all the angles are congruent to each other. In that case, you could figure out what one angle was. Since they're all the same, you could use your polygon interior angle sum theorem, n minus 2 times 180, to find out what they all are. And then since they're all the same, divide by n, or how many there are, because there are the same number of sides as there are angles. So this formula is only if the shape's regular, and it's to find just one of the interior angles. Now ask yourself, what happens with exterior angles? In previous videos, we've talked about how you find an exterior angle. You extend a side, and the exterior angle is formed between a side of the shape and the extension of the other side. And so these three, for this black triangle, the red exterior angles, what is their sum? Pause, add them up, and see what you get, and then press play. They add up to 360. What if we add another side? Pause, add up those this time four red exterior angles, and see what you get. They also add to 360. And it turns out that any polygon, no matter how many sides, the sum of exterior angles will always be 360. And you can think about it, because if you walk around the outside of a shape, it's always 360 degrees around the outside. Whereas when you add sides, the interior angles will change, will increase. So here's a summary slide if you'd like to take a picture, but it's only a summary for regular polygons. So pause and solve this practice problem, and then press play for the solution. Basically, what it's asking you is to find, you're given a regular hexagon, n is 6, and you're asked to find what one interior angle is. So we can use the corollary where we find out what all the angles are, n minus 2 times 180, and divide by how many we've got, divide by n. And we'll put in n is 6 for a hexagon, so we can plug that in, and we find out that one interior angle of a regular hexagon is 120 degrees. So pause the video, and this time find what one interior angle is for a regular nonagon, where n is 9. We're going to go through the same steps. First, we'll find out what all of the interior angles add up to, n minus 2 times 180. And then we'll divide by how many we've got, 9 in this case. So we'll now substitute 9 for n, and we find out that every interior angle of a regular nonagon is 140 degrees. What if the polygon is not regular? What if it's not a regular polygon at all? What if all the sides are different lengths and all the angles are different? Pause the video and solve for y, and then press play. The first step is you need to ask yourself, how many sides are there? 1, 2, 3, 4, 5. In this case, n is 5. How can I figure out what the measurement of angle y is? The first thing I can do is say n is 5. And so I can use my interior angle polygon sum theorem to figure out n minus 2, but I'll put n is 5. 5 minus 2 times 180 is the sum of interior angles. And then you can add up all these angles and make your equation, because you know all but one of the angles that you need. And you can solve for your missing angle. So pause, find the measure of angle G, and then press play. N is 4, 1, 2, 3, 4. So the first thing you want to do is use the polygon angle sum theorem using n is 4, and you find out that the sum of interior angles is 360. And then you add up what you've got and you create your equation, because all the angles have to add up to 360, and you can solve for your missing angle. Now notice, at every vertex of the polygon, the interior and the exterior angle pair is always a linear pair. Therefore, that pair of angles will always be supplementary. So here we have a blue 1, 2, 3, 4, 5, a blue pentagon. And here we have an interior angle, red, 65 degrees. And here we have the exterior angle, black, is 115 degrees. So notice, together they form a linear pair. And that's always going to be true of the interior-exterior angle pair. So with that in mind, pause, and with all that we've done so far in mind, pause and find the measurement of angle 1 for this regular octagon. We know that in regular polygons, the sum of exterior angles is always 360, and if n is 8, and they're all the same, you could do 360 divided by how many there are and get they're each 45. Here's another practice problem. Pause, solve on your own paper, and then press play. If you're given that the measure of one exterior angle of a regular polygon is 30 degrees, what will the interior angle be? And find the number of sides. Well, the first thing you can do is know that the interior and exterior angle pair is always going to be a linear pair, so they're always going to be supplementary. And so you know that they will together add up to 180, and therefore that interior angle has to be 150 degrees. It's regular, so they're all the same, and we know with regular polygons, if the sum of all the exterior angles is 360 and they're all the same, so if we divide by how many sides there are, we get what one of them is, and we're told one of them is 30 in the given information, and so we can solve for n. We can multiply both sides by n to get the n above ground, get it to cancel, and then divide both sides by 30, and we get our final answer. It should be a 30. Pause, practice this one, and then press play for the solution. Here we're told that the sum of interior angles for some mystery polygon is 2,880. But we wonder, how many sides are there? It doesn't say it's regular. That's not part of this problem. It just tells us the whole sum is 2,880. And so what we can do is we can use our polygon angle sum theorem, knowing that the sum of interior angles for this mystery, for any convex polygon, will be n minus 2 times 180. Well, we're told in this problem the sum is 2,880, and we just have to solve for n. So we do our inverse operations. We can divide both sides by 180, and then we can add 2 and get, this must be a polygon with 18 sides. And that does it for for polygon sums, interior and exterior angles. So I will leave you with this little mother-daughter lion cub situation and wish you a great day.